Okay, today we are finishing up nomenclature. We're going to do nomenclature with our polyatomic ions, ternary nomenclature, and we're also going to talk about acid and base nomenclature. Okay, so pretty much let's just pick up with number 15. I'm going to ask one question, and the first question is going to be, is it ionic or covalent? And then I'm going to ask, if it's ionic, whether or not the metal has one or more charge. And then we'll go from there and name it. So the first one, that's just two ions shoved together, so it's obviously an ionic compound. And what is that called? Really loud so the people at home can hear you. What is it? Ammonium nitrate. Nice. Ammonium nitrate. Okay, the next one, is it ionic or covalent? Ionic. Is the metal potassium univalent? Does it have more than one charge or one charge? One charge. So name what you see. What is this called? Potassium nitrite. All right. Next, ionic or covalent? Ionic. Calcium, does it have more than one charge? Nope. So name what we see. This is tricky. Calcium perchlorate. Okay, let me teach you a little trick here about the pattern. I have it on the board here, but I'm going to write it on the smart board so people at home can see it. When you're dealing with your polyatomics that are all related to those halogens, there's a pattern that you can apply to the fluoride, chloride, bromide, and iodide ions. So how it starts is this. I like to start in the middle. There's ClO2 minus 1 and ClO3 minus 1. Okay. We also have ClO minus and ClO4 minus. Looking at the middle, this is going to be something ite, and this one is going to be something what? 8, because ites have less than 8s, right? So again, all of these are -1. So you can use bromine, fluorine, chlorine, or iodine for these. The one, since this is on the low end, that has only one oxygen, has what prefix? Hypo, blank, and since it's on the low end, it ends with the ite. So this is hypochlorite. Down here, this is on the high end, so it ends in 8. What's its prefix? Per. This same pattern works for all of those halogens. Knowing this pattern, you now know 16 polyatomics. Okay? So, and they're all -1s, all across the board. So that would be a quick way to do that first one, the one we just did, the perchlorate. Anyway, back to the next one. CuCO3, ionic or covalent? Ionic. Does copper have more than one charge? Yes. So what would this one be called? Copper 2, because that carbonate has a -2 charge. So that would mean the copper has to have a +2. If I want to be fancy and get all Latin, what would the Latin version be of that copper 2? No, it gets high. Remember, this could be +1 or 2. So 2 is the higher, so that would be cupric carbonate. Okay? All right, up to the next side, we have NaCN. Is that ionic or covalent? Ionic. So what is it called? Because sodium only has one charge, so sodium cyanide. There are the two polyatomics you need to be concerned with that have an IDE ending, the only polyatomics with an IDE ending. One is cyanide. What's the other? Hydroxide. All right, ionic or covalent? Ionic. Does barium have more than one charge? Nope. So what do we call it? Barium sulfate. The next one, ionic or covalent? Ionic. Does mercury have more than one charge? Yep. What's the charge on this mercury? Or mercurous? What's the last name? Oxide. Okay, This one is kind of a little special situation. Right here, this CO3 minus 2, before it's in anything, is called what? Carbonate. You have one of two options on this. That H can be said, you could say bi, or you could say hydrogen. So you could call this bicarbonate or hydrogen carbonate. I'll take either. Where do you see this happen? You see this happen mainly with the sulfate, the carbonate, and the phosphate ions. We'll talk more about this when we get to acid-base chemistry, but those are really the only three polyatomics that will have hydrogens randomly popping on the front of them. When you put the hydrogen on there, it is a positive 1 charge. So carbonate originally being -2, when you put a +1 on it, becomes -1, hence leading to needing only 1 sodium. So what would this be called then? Sodium bicarbonate, also known in the real world as what? Baking soda. Baking soda. Or sodium hydrogen carbonate. You can call it that as well. Okay, so now you're going to hate me because we're going to go the opposite direction, and we're actually going to go around the room, and we're going to try this. I don't get mad when you're wrong. Where I get mad is you sit there and you don't try. If you need to, get your polyatomic list out, okay? Whatever you need to do, you're going to be fine. We'll all help each other through all the problems. So I'm going to start with Sophia. Lithium carbonate, what would that formula be, Sophia? Nice. Li2CO3, lithium's a +1, carbonate's a -2. Okay, Mitchell. Magnesium hydroxide. Correct. We have MgOH2, and you need to have parentheses there because you have 2 hydroxides. So you've got to have parentheses when you have multiple polyatomics. I do not want parentheses if there's only 1 polyatomic. That just looks stupid. We don't want to look stupid. Okay, Ben, you get a good one. This is a sexy one. O4. MnO4 -2 is permanganate. So, I mean -1, sorry. MnO4 -1 is permanganate. This is Pb +2. So try it again. Correct. Perfect. Led to permanganate. That was a tough one. Okay, Trevor. Oh, that's right. We talked about this last period. This is the, I don't know what polyatomic I want to be. I either want to be an ite or an 8. So what I did last period, which one do you want, ite or 8? Your call. We're going to get rid of this I then. So this is going to be chlorate. So chromium 3 chlorate. That's okay. All right. Good. Chlorate's -1. The chromium's 3, so you need 3 chlorates. Very good. Now this one made me laugh too, because this poor zinc got nitrated, and that was just painful, I think, when it got nitrated like that. So Noah, obviously take the D off. Good. ZnNO3 2. Okay, Shriram. Shriram. I'm not going to get it. You just need to keep saying it. Maybe someday, Christmas time. Shriram. Shriram. SrSO4, because each of those -2 and a +2 balance out. Good. Raghav. Did I say it right? Okay. FeCN3. Very good. Okay, Alex, let's get some acetate action going. That's an important polyatomic. Acetate is huge in Chem 2 when we get to acid-base chemistry. It's the consummate ideal weak acid, and we'll be using it a ton. So get to know acetate. All right, good. Y'all did great. Let's move on to acid nomenclature real quick, and then we're going to put it all together and do more practice. When we're doing acid nomenclature, there's a couple categories we look at. The first is binary acids. Binary acids are acids that just have two things in them, an H with one other element. Okay? And the way we name binary acids are hydro, blank, ic, acid. The next category is the ternary acids. These are the acids that have polyatomics in them. Well, let me go back and just make another statement about these binaries, and I just thought about it. Anything in the in the acids that are binary, that anion ends in IDE. Fluoride, chloride, bromide, all of those fall in this category. And I'm telling you that for a reason. And when we get to it, I'll tell you why I said this. So let's go back to the ternary. The ternaries have your polyatomics in them. If your polyatomic ends in ITE, the acid is blank us acid. If the polyatomic ends in ATE, the acid is blank ic acid. There was a saying that you learned, and mine's going to be a little different than Miss Rozier's was, and I'll have her say hers in a second, but mine was ic I ate a humongous bite. And how that works, it pairs your ion with your acid name. If your acid ends in ic, the acid ends in ic, the polyatomic that's in the acid ends in ate. If the acid ends in us, the polyatomic ends in ite. What's your saying? Oh, you do? Okay, I thought you did something with icky something. Icky ate a humongous bite. Oh, that's close. I thought it was more different than that. But anyway, so that'll help you remember. Let's start out with number 17 up here. And number 17, the first two look like they're the same thing, right? Well, they're really not, and this is just a subtle difference that I want you to be aware of. So when they throw it at you on the AP in a problem, you're not going to freak out. If you have HCl in a gaseous form or any acid in a gaseous form, you name it as if it's an ionic compound. Acids are technically supposed to be solutions. And so when we use the term acid, we're assuming it's a solution. So that's why this aqueous solution we're going to name like it is an acid. This being a gas, we're just going to name as if it were an ionic compound. So name exactly what you see here, not covalent, ionic. What would that be? Hydrogen chloride. That's it. Here, this aqueous, now we can name it as an acid. What kind of acid is that? Binary, so hydrochloric acid. Okay, the next one, is that binary or ternary? Ternary, it's got a polyatomic in there, right? What's the name of that polyatomic? Perchlorate. 8 then would be something ic acid. You just change the ending of that polyatomic from perchlorate to perchloric acid. Don't let the 2 here scare you. The only reason there's a 2 in the next one is because the charge on the ion is -2. So that does not affect the name at all. You still name the polyatomic, which is carbonate, so it's carbonic acid. All right, HClO, what's the name of that polyatomic? Hypo, not hypo. Yeah, it is hypo. I'm thinking hydro. This is what I'm about to say. This is why students get confused. It's hypochlorite, so that's which acid? Hypochlorous acid. And just like I did there, students tend to confuse the hypo and the hydro. Be very careful. Hydro is for binary acids only. Hypo refers to the polyatomic that has that 1O attached to the halogen. H2SO4, what's the name of that polyatomic? Sulfate. So it's, now, very good. Y'all said sulfuric. So a lot of students want to go sulfic. And I understand why you want to do that. I wanted to do that the first time I learned that too. But sulfur and phosphorus, kind of weird. Instead of sulfic, it's sulfuric. Phosphoric, it's not phosphic, it's phosphoric. Okay, those are the two weird ones. So this would be sulfuric acid. Knowing that this is sulfuric, what would this be? Sulfurous. H3PO4, what's the name of the PO4 polyatomic? Phosphate, so this is phosphoric acid. Exclamation point, that's not part of it. All right, now let's keep moving on. Where did I leave off? Who did I leave off with? You were the last one. Okay, so we can move on to Haley. Haley, hydrosulfuric acid. What polyatomic makes up hydrosulfuric? Okay, it's not no, you're right, it is. It's not H3S. See, I got it backwards again, but it's not H3. What is the S charge from the polyatomic table, the oxidation state? -2, right? Okay, so if it's -2, how many H's do I need? 2. So what's the formula? H2S. Good. Okay, moving on to Zach. Nitric acid. What polyatomic ick do we need? Nitrate. So what would the formula be? Good. All right, your son. No, son. I'm going to get it. I'll practice it. It'll be fine. This is the one I wanted you to be careful with. This is not a binary acid, but the polyatomic ends in IDE, so that's why it's named this way. So the polyatomic that comes from here is the cyanide polyatomic. So what would the formula be? Correct. HCN. Okay, Philip. Very good. The polyatomic he chose was periodate. Made it 1 negative charge attached to 1 H. Okay, Johnny. Very nice. What is this in the real world? Acetic acid. If you were to mix it with sodium bicarbonate, you make a volcano. What is it? Vinegar. See, now you can make a volcano using chemical terms. This is vinegar. Sodium bicarb was baking soda. I'd jot that down if I were you. It's kind of an important piece of information. It's one of those real world things I want you guys to know. I want you to be able to play Trivial Pursuit successfully at any local restaurant / sports bar. This would be one that would show up on many of those questions. All right, hydrobromic acid. We're up to Lauren. Nice. Okay, phosphorus. We're up to Lincoln. Nice, H3PO3 because it's phosphite. And then Winborn, poor Winborn gets oxalate. Oxalate. You're Winborn, right? Yeah, you're Winborn. Correct. Oxalate is C2O4 - 2. It's actually a really important oxidizing agent. So it's something we're going to use a lot of. C2O4. Okay. We are going to now move to all this crazy nomenclature found toward the end. We're going to continue around the room. For those of you listening to this video at home, I don't have room to write this stuff down. So I'm going to be saying the answers out loud. If you're at home, you could be taking notes on this. For those of you in the live studio audience, you can write stuff down as you need it. This is one of those situations where you might not need to write the answer to every single one of these down. I want you to write the ones that were a little bit hard for you. Some of them you're going to blow through without a problem. There's also going to be an issue that's going to come up here in a second that I need to address. But let me find this sheet. All right, so we were at Maddie. So I've got a Maddie and a Madison right next to each other. That is great. And you both have to have blonde hair, long blonde hair, both parts on the right side with no bangs. Thank you. Thank you. I think one of you needs to go get bangs this weekend to help me out. No? Neither one of you are willing to do that for my sanity. Great. Okay. Maddie, you need to wear your glasses. Apparently in this picture you have glasses. Okay. Dang it. Okay, so starting with, we're going to start in section A with A. And this is one of those you probably don't need to write down, folks, but go ahead, Maddie, name that. Carbon monoxide. Okay, here's another one, Madison, tough one. Carbon dioxide. All right, GR. Sodium carbonate. Good. Moving on to D, Alyssa. Good. All right, you're getting a tough one. This is what I need to talk about. We're going to name this. Do you remember this, Jesse, as an organic compound with one C? Did you take pre-AP? Okay, what was an alkane with one C called? Something ane. Butane is 4 carbons. What would 1 carbon be? Someone help them out. Methane. Remember? So as far as nomenclature goes, I'm only going to hold you responsible for the alkanes. And what they are C's in a line attached, all surrounded with H's in every single empty spot. Okay? What I do want you to know is 1 through 10. It's not hard, but those might pop up on AP equations and things like that. So a 1 carbon alkane is called methane. And I'll give you the general formula. It's CnH2n plus 2. So if you have 1 C, you're going to have 4 H's. If you have 2 C's, you're going to have 6 H's and so forth. 2 is what? Ethane. 3 is propane. 4 is butane. 5 is pentane. 6 is hexane. 7 is heptane. 8 is octane. 9 is nonane. And 10 is decane. A friend of mine teaches for 1 through 4, me eat peanut butter. That's high class, great grammar. Awesomeness. I eat peanut butter as well, but me eat peanut butter, apparently. All right, so I kind of will let you off the hook on that one, Jesse, but I am going to ask that you do the next one, which is G of part A. Nice, sulfur dioxide. Paige, can you give H a try? Good. Sulfur trioxide. And I'm repeating it because of the video, guys, because they can't hear what you say. I don't like to hear myself talk this much normally. So don't take offense when I repeat what you say. Brianna, how about the next one? Don't, you're just panicking because there's a bunch of people listening to you. So it's ionic, right? It's got a metal. So you know that metal is Na is sodium. And then SO4 minus 2 is a polyatomic sulfate. So what's that called? Yep, sodium sulfate. Zach. Correct. The next one I'm not going to make Eileen do because it's mean. That is a polyatomic called thiosulfate, S2O3-2. So the name of that is sodium thiosulfate. You're not going to be accountable for that in any sort of nomenclature, but it does show up in problems a lot, especially in, again, electrochemistry and redox. So just write it down, accept it. Sodium thiosulfate is the name of the polyatomic, thiosulfate. So Eileen, go to M. Sulfur what? Not D, there's two, so mono di. Sulfur dichloride. Because it's all nonmetals, that's covalent nomenclature. You got to use the prefixes. Okay, Mr. Schindel. And that's a miss. Take off the 2 on the sulfur there, everybody. Go ahead and just name it. Sulfide. It comes from the periodic table, the S does. So it's just IDE ending. You only have an ite or an ate if there's those oxygens there in the polyatomic. Okay, we're going to move on to part B. And what we're going to do here, Adam, is you're going to put those 2 ions together and say the formula. For instance, I'll do A for you. A is going to be Na2SO4, and then I want you to name it. That's called sodium sulfate. Okay? So do the next one, B. Nice. CaSO4 is calcium sulfate. Perfect. Okay, Leah. Good. NH4 2SO4, and what's that called? Ammonium sulfate. Good. Part D, we'll move on to, it's Mallory, correct? All right, Mallory. Okay, well, look at that N. What's the charge right there on that page? 3. So we need 3 pluses. So it's Li. We want +1 on the left, -3 on the right. We need 3 pluses. So Li 3N. Do you see that? What's Li3N called? Lithium. Good. Not nitrogen. It ends in an IDE. So lithium nitride. All right. Start back from the beginning. Sophia. Good. Ca3N2. And what's that called? Perfect. Calcium nitride. Mitchell. Nice. Cr2, CO3, and what's that called? I'm going to see if it trips you up. Go ahead. Yep, we tripped him up. How did we trip him up? What did we do to him? What can you tell me about chromium, Mitchell? Does it have more than 1 charge? Does chromium have more than 1 charge? It sure does. So what's the you have to tell me with the Roman numeral what the charge is. And it tells you on the page what chromium's charge is. Chromium 3 carbonate is the name of that. Chromium 3 carbonate. And he's not the only one that gets messed up on that. Pretty much everyone who hits that problem forgets that Roman numerals exist. So we got to get those Roman numerals in there. Okay, we're going to move on to part C with Ben. Ben, just tell me the name of that compound. A. C. All right. Oh, we got you too. Can iron have more than 1 charge?
Iron 2.
Close. Oxygen is 2, correct? So there's 3 of those at a -6, correct. So this has to be iron 3 oxide. So A is iron 3 oxide. Moving to Trevor, iron 2 oxide. All right, Noah is next on part C. Perfect. Cobalt 2 sulfide. Have confidence, Noah. You were right. I don't want to say it because I'm going to screw it up again. Shriram. Next one. It's D. You're on D. Mm-hmm. Correct. Cobalt 2 sulfate. Perfect. Raghav. Yep. Chromium 3 chloride. Nice. Alex. We got a big charge here. Perfect. Chromium 6 oxide. Okay, Haley. Yep, perfect. Potassium only has one charge, so she doesn't have to give me a Roman numeral. Potassium chromate. All right, Zach.
Potassium dichromate.
Yep, potassium dichromate. Sun. Manganese 4 oxide. Good. Philip. Lead 4 oxide. Perfect. All right, next part. I'll help you out. I know I said you're really not responsible for these Latin and whatever names, but I do need you to know the multiple charges. So today I'll be nice. I'll help you out a little bit. We know Ic is the higher charge, Johnny. Iron can be what, 2 charges? Anybody? 2 and 3. So this iron's going to have a 3. So what's its formula? Nice. Fe parentheses OH3. Okay, Lauren, cuprous is the lower of the 2 charges, which would be what? Good. It would be 1. So if copper is 1 there, what's the formula? Perfect. Cu2S. Okay, Lincoln, I'm not helping you on that now because it's telling you. Oh. Okay, you were correct with the 3. Cu3. Phosphide's a negative 3. Nice. Cu3P2. Good. Windborne, D. And I'm going to talk about this in a second. Go ahead. ZNSE. Can anyone tell me why this is actually not appropriate nomenclature, what they did here? Windborne? Correct. Zinc's only 2, so the Roman numerals are redundant. Okay, Maddie, E. What? I don't. It's okay. I don't need to change it. Sorry. What? Na2S is correct. Perfect. Na2S. All right, Madison, ferrous cyanide. Ferrous is lower. What are the 2 possible charges? 2 and 3. So this would be Fe plus 2. Correct. FeCN2 with parentheses around that CN. Okay, GR. Yep. Ammonium iodide is NH4I. Okay, Alyssa, don't let it scare you. It sounds really, really complex. Osmium 8 oxide. Okay, how about yeah, that's good, but how about an element symbol for osmium? OS, good. OS, you were correct. O4. OSO4, perfect. All right, Jesse, give me some platinum. Nice, PTCl4 is perfect. All right, the next one, J, tungsten. Close. This is actually one of my favorite elements because it's weird. What's its letter, guys? W. That's 6. So each oxygen is a negative 2. So how many oxygens do we need to get 6? 3 of them. So, yep, WO3. Cuprous cyanide. Brianna, cuprous, the lower is plus 1. Good. CuCN. All right, Zach, cobaltous hydroxide. COOH2. He got it because cobalt can be 2 or 3, so he chose the lower one. Good job. Don't freak out, Eileen. What I want you to do is forget the dihydrate for a second, and I just want you to name gold 3 cyanide. Oh, I see what you meant, Noah. Sorry, people at home. I didn't change the page. We are here, people at home. Oh, I thought you meant I didn't change the zinc. to 2. Yeah, sorry, I didn't listen to Noah. I should have. All right, so gold 3 cyanide. Okay, but hold on. What's cyanide's polyatomic? If you need to do this to name, write down each ion, and I bet you when you see this, you can name it faster. So now that you see this, put those together to get a balanced charge. Correct. That's the gold 3 cyanide part. Do y'all remember those in pre-AP? I know you guys did a lab where you found the empirical formula of a hydrated crystal, and it was all crystally, and then you made it powder, and you weighed it, and you found how much water left and all that stuff. You had to get the mole ratio. Well, the hydrate was dot with the hydrated crystal was indicated by this way, and the fact it says di, it means it has 2 waters on it. Okay, so a hydrated crystal just has a dot with waters on it, and the number is going to be the same prefix as those you learned in covalent nomenclature: mono, di, tri, tetra, penta, and so forth. Okay? Okay, the next one, N. Chromium. Where are we? Who's me? Matt. All right, Matthew. CR. Are we on N? Yeah. Say that again. CrO3. Good. CrO3. Atom. Yep. VF5. P. Leo. Nice. V2O5. And then Mallory. LIH. Good. All right. Last part we're going to do is the, oh, we're not done with this one yet. Sophia, T. Okay, let's help you out. Tin can have what 2 charges? 2 and 4. It gets high, so it's tin 4. SNO2. Good. Mitchell. Cl. SnCl. Not ClO. Chloride has the IDE ending, so it's just the Cl, and it's not 4. Stanic is a +4. Stan-S would be a +2 then. So it would be SnCl. Cl2, right? SnCl2. All right, Ben. ZrCl4. Nice, ZrCl4. Okay, so now we're going to do these acids real quick, and then we are done. A through M on part E. You're writing the formula. Trevor, why isn't acid written for part A? Why is that? For E, letter A. What was that reason again? Why is it hydrogen fluoride instead of hydrofluoric? Because it's a gas. Remember, if it's a gas, we name it like we see it. So this is an easy one to write the formula for. What is it, Trevor? HF, that's it. All right, Noah, B. HBr, nice. Shriram, C. HBRO, correct. Raghav, D. Okay, these aren't all acids, and I'm glad that we threw in some normal ones. This is just a covalent compound. So how about SO2? Sound good? Okay. I'm going to give you a chance to redeem yourself. Do the next one. It's not an acid either, just FYI. Sure. Good, NiOH2. See, you're back. Alex, S. Good. Haley, not an acid. G. Good. Yep, OSO4, perfect. Zach, the next one. AuCl3, that is correct. Sun, Pi3. Okay, Philip. Cu, okay, it's not IO4. IO4 is per. iodate. So it's just IO3. So Cu, and he said IO3 too, which is absolutely correct, because Q prick implies the +2 copper, not the +1. I don't know if, is peroxide on your polyatomic sheet? No, so I need you to add this on there. This is one of those every year I forget to add. O2 minus 2 is a peroxide polyatomic. So for that one, you would use O2 minus 2 as your anion. So kind of wing it, Johnny. What do you get when you do that? Yep, Na2O2. Okay, Lauren. K. No, you're L. You're L. Sorry. Yep, K2C2O4. Perfection. Last but not least, Lincoln, let's close out the day. Don't make a mistake. We want to end on a good note. Yes, perfect. The bi puts the hydrogen in front of the sulfite, and that drops it to a -1 charge, so we only need 1 sodium. NaHSO3. I'm impressed for the most part. I think 90% of you are on it, and I think you're doing a great job. And we'll pick up on moles and mole calcs tomorrow. Good job.